Hey, today we're going to talk about 3.2, K-selected and R-selected species. So you can go ahead and check out the Enduring Understanding, look at the learning objective, and pause the video, review the essential knowledge as you set up your Cornell notes. So we have right here a graph showing two different things. We have the carrying capacity and we have a population. The carrying capacity is indicated by the letter K. Oh, notice, K. That's gonna be important soon enough. And we have R. Oh, look, RR. So biotic potential just shows the growth of a population when there is an abundance of resources. So this is showing exponential growth over time. If it were graphed out how it looks in real life, eventually this population will level out because no population can ever grow exponentially forever. Eventually resources will run out. So when that happens, the graph will eventually have this type of a look to it, and we'll be discussing this more in future lessons. Now, between K-selected and R-selected species, K-selected species have quality. R-selected species are more about quantity. So K-selected species, examples, chimpanzee, elephant, whale, human. So what are some characteristics? They have a long lifespan. They have later reproductive maturity. In other words, it takes a few years for organisms, or months relative to their size, but it takes a little bit longer in their life cycle to reach maturity. They have fewer reproductive events. They have a smaller number of large offspring. The populations are slow to grow, and they hover near the carrying capacity. And the reason they're called K-selected species is because their populations pretty much are near that carrying capacity. Now, when we're talking about R-selected species, examples are zebra mussel, dandelion, fly, basically most insects, and fish. All of these are typical R-selected species. Now, whatever K-selected has, R-selected is kind of the opposite. R-selected species have a very short lifespan. They have early reproductive maturity. They have many reproductive events. They have many small offspring. They have fast population growth, and their population is variable because the growth is so fast. So what does this look like when we graph it out? You have the carrying capacity. The K-selected species tend to hover at or near the carrying capacity, and the R-selected species will be highly variable, overshooting and undershooting the carrying capacity. Because they reproduce so rapidly, they can overshoot this and then have a massive die-off, and then reproduce, massive die-off, so on and so forth. And this is very typical of an R-selected species. So this is actually not like something is specifically K or specifically R selected. It's more of a spectrum. So some organisms are very R-selected species, like a zebra mussel. There can be millions of offspring of a zebra mussel in a particular year. But then there might be some, like a fish, may have fewer reproductive events, may offer some sort of care for their offspring. But basically, it's not either K or R. There is like I said, there is a spectrum. So they fall somewhere between K and R. Like rabbits. Typically, we might think of rabbits as, at least compared to humans, rabbits are very R-selected. However, it still takes them a little while to be reproductive or be mature and have a reproductive event. So it is a little bit more K than typically a lot of R species, but it's a little bit more R than other K species. A wolf is another example. It's a little bit more K than a rabbit, but a chimpanzee and human are pretty much as K-selected as you could get. Now again, this is a spectrum. It doesn't mean you're either K or R. You can have properties of both. Now invasive species are typically going to be R-selected species for the most part. Some of these, we have a Norway maple, and Norway maples are invasive. At least they're invasive in Brooklyn, in Prospect Park especially. There are Norway maples like very common. We have the lionfish. These are invasive in Florida and the Caribbean. We have the brown tree snake, which is invasive in Guam, and a lot of snakes are invasive in Hawaii. We have the cane toad, which are invasive in parts of the United States, became very invasive in, I think, Australia too. We have the Asian longhorn beetle, which are invasive in New York. We have the zebra mussels, which are invasive in New York and all around North America. We have the kudzu vine, which is invasive in the southern United States. I don't know if it's made it to New York. We have purple loosestrife, which was invasive. It's invasive where I'm from in Minnesota, and it's an aquatic or a wetland plant. So these were found a lot of times in lakes and ponds. And we have the nutria, which is basically a giant rat, and they are now invasive in parts of Louisiana and around the Gulf Coast. Invasive species have rapid reproduction because they have no natural predators. They also have a very wide range of tolerance, which means they're typically going to be generalists, and a lot of generalists are also R-selected species. Because of this, there's going to be competition with K-selected species, and that can lead to biodiversity loss. Okay, for our FRQ practice, I would like you to look at this table, and we have species A and species B throughout many different years. I would like you to describe the relationship between the population densities of the two species of aquatic invertebrates in the East River. So in your response, I would encourage you to use the vocabulary terms from today's topic. So I hope that this was informative to you. I thank you very much for your attention, and I look forward to seeing you soon. Thank you.